Let's take a look at one more past paper question. In this past paper question, there is part A and there is part B. Part A deals with the area of the shaded region. Part B deals with an interesting thing. It's a revolution not about the x or the y axis. It's about the line L1. Well, let's first look at part A. All right. Now, part A, we want to find the area of the shaded region. But before we carry on the calculation, you must pay attention that you should split into two partitions for this question. Because in the partition 1, in number 1 here, if you look at the element, that is the red greater than the blue. So it should be the red subtract the blue for the elements in number 1. On the other hand, in part number 2, it should be the blue subtract the red. Alright, so part 1 and part 2, they have different equations. That's why we need to separate the boundaries very well. Right, for this one, x is 0. For this particular point, we have it here that x equals to 4. And finally, for this point, we have x equals to 5. Alright, so region 1 is the integration from 0 to 4. Region 2 is the integration from 0 to 5. So let's deal with them separately. For part 1, it is the integration from 0 to 4. We have the red y subtract the blue y, alright, and then we do an integration with respect to x. That is the volume of part 1. That is the area of part 1. In part 2, we have the boundary is different. It's from 4 to 5, right? When we deal with area and volume with partition, you must pay attention to this. That is the blue y subtract the red y, right? So that is for part 1 and part 2. We have different y's, blue and red. We have different regions. We have different integration boundary. So for the red one, that is the red one. That is the red one. Okay, that is the blue one. So red minus blue, we have the integrate from 0 to 4 minus x squared divided by 2 plus 2x integrate the dx, alright, and that goes to x cubed divided by 6 negative, right, plus x squared. We do this integration from 0 to 4, and the answer is 16 over 3, right? Right, that's part A. You may pause for a while to see how come this number end up as this one, alright? Alright, and then for part 2, that would be the integration from 4 to 5, right? The blue minus the red. The blue minus the red ends up into something like this. X squared divided by 2 minus 2x dx, alright? And that would be x cubed divided by 6 minus x squared. It's from 4 to 5, alright? And then, of course, you put back the numbers 4 and 5, it goes to 7 over 6. So the total area in part A is just 1 plus 2, and that is 16 over 3 plus 7 over 6, and it ends up 13 divided by 2. This is the answer to part A, the area. There are two things to note in this area. The first one is the partitioning. In part 1 is red over the blue, so we have the red minus the blue. In part 2, we have the blue over the red, with the blue above the red, so we have a different equation for the integration. And secondly, will be the boundaries. In part 1, x is from 0 to 4. In part 2, x is from 4 to 5, right? So these are the major items when you want to construct the equations for the integration of area, and even for volume. Alright, okay, that is part A, right? In part B, we want to deal with the volume, but the funny thing is the axis of revolution is not the x or the y axis. It's kind of like an offset axis. It goes, somewhere else. So we have to reconsider the radius, alright? The rotation, you will have something like this, right? The object of the rotation will be kind of like, a spherical shape like this, and then with a circular disc, kind of like this, right? It will be an object kind of like this, and the radius is always the red one minus the purple one, right? The red y is all the way here. This is the red y, alright? The y will be here, and then there is a purple y, alright? The purple one is always 4, right? Because L1 equation is y equals to 4. So if you revolve it, just the red, that's just this part, that the radius will be y minus 4. Alright, this part will be y minus 4. That is the radius of the revolution. So for each of this disk, if you do the rotation, you have a disk. Alright, the radius of this disk is not y but y minus 4. Alright, so we have the volume should be pi y minus 4 take the squared. Alright, and then dx. We integrate from the smallest x is 0, to the largest x is 5. There's no need to partition because it is squared, y minus 4 squared. So whether it is y minus 4 or 4 minus y, right? If you look carefully, this one, it should be 4 minus y. But anyway, we are taking the square. So it doesn't matter whether it is 4 minus y or y minus 4. It ends up the same squared. Alright, and that goes to from 0 to 5. Y minus 4 will be minus x squared divided by 2 plus 2x. Take the square and then we integrate this one. Alright, to do this integration, the best way is to expand the square. So we have x4 over 4. Alright, minus 2x cubed plus 4x squared. We do this integration from 0 to 5. And that ends up x fifth divided by 20 minus 1 over 2 x fourth plus 4 over 3x cubed. Right, don't forget the pi, right, from 0 to 5. And if you put the 5 and 0 into the bracket, you arrive at this answer, 125 divided by 12 pi. Alright, this is the volume. Right, so there's an offset axis. Try to pay attention between these two. Right, one is pi y square minus pi y2 square. If you do not have color, then you use y1 y2. Alright, that is for a whole. Alright, if you have the outer radius is purple, the inner radius is orange, then you have this cross section area equals to this one. Alright, however, there's a very similar thing. If you have pi y1 minus y2 squared, right, it's totally different. That means that, what does it mean? That means the axis is offset. You have this is y2, this is y1. Alright, and if you rotate about this line, if you rotate about this orange line, then you have the radius is offset. It's only y1 minus y2, the radius. So pay attention to this yellow box. They are not the same. Alright, so in this particular example, it's not a hollow solid, it's a filled solid, but the radius is offset by the purple y, right, by y equals to 4. So this is the end of the investigation on finding volume of revolution. Now there are some past paper questions, in particular the questions on 2014 and the past paper, the practice paper question. Some of these questions they use shell method. Alright, year 2014 or the practice paper, they use a method what we call the shell method that is out of syllabus now. Right, it was in the old syllabus, that's not anymore. Alright, so you don't have to worry about these two questions on the past paper. The method that we use is called this method. Alright, but in these two past paper questions, it has to make use of a method called shell method, which is not covered. So you don't have to worry about these two questions. Okay, so this is everything about integration. Thank you.